All right, in section 2.6, we're going to be talking about compound inequalities. And compound inequalities are used to compare two inequalities together. But before we can do inequalities, we want to talk about how we compare sets of numbers together. So if I have two sets of numbers, we can use things like intersection and union to talk about the elements that are involved in both sets. So the intersection of two sets A and B, written as A intersect B, that's kind of an upside down U, includes all the elements that are common to sets A and B. The union of two sets A and B, written as A union B, includes all the elements in set A, set B, or both. And one of the things that we use to describe elements that are common, like in the intersection, notice we use the words set A and set B. The and connector is important here. And then if you notice for union, when it includes all the elements in set A, set B, or both, notice that one uses an or connector, just like we use and or in English. So if we look at two sets of numbers, like A and B, set A, we have the elements of set A are these numbers, -5, -3, -1, 1, 3, and 5, and then set B, the elements are 0, 1, 2, 3, 4. And if we talk about the intersection of these two sets, we want to find out the set of numbers that are common to both. And by looking at the sets, we can see that it looks like 1 is common to both. So 1 would be in the intersection, and then also 3 is common to both. So 3 would be in that. So these numbers, the intersection, notice are in. So these are the elements in A and B. And we have that and connector. If it's an intersection, the intersection includes all the elements in both A or B. So they're all the elements in A and all the elements in B together. So we could just list these, all the elements in A, -5, -3, -1, and then just fill in all the elements in B too. So -1, 0's in B, so that's in the union. And then 1, 2, 3, 4, 5. So these are all the elements in A or B. And it's basically just a list of every element used in both, right? So a Venn diagram, and we can always find the intersection and union of sets that are just discrete, a discrete number of elements, a listed number of elements. We could look back and forth and see which ones they have in common, and then we could list out all the numbers that are used. Well, a Venn diagram is kind of nice for this too. And a Venn diagram is used to visualize the intersection and union between sets. So the circles that are labeled A and B here, you notice they're overlapping. So all the elements in A would be within the circle, the left circle, and all the elements in B would be in the right circle. But you notice the overlap here. There's an overlapping section here. And what that means, if the element is listed in this area, this overlap would be basically the intersection. This is in A and B, right? And this would be A intersect B. So we know that the intersection of these two elements, or of these two lists, are 1, 3. So in a Venn diagram, the 1 and 3 would be inside that kind of football shape representing that overlap. The rest of the elements in A would be just in the circle of A, but not in that overlap. So like -5, -3, -1, and 5 would be the rest of the elements in A, and those would be in the circle of A, but not in the overlap. So right now, if you look at A, the circle involving A, every element in A is within that circle. And then for B, we want the elements in B that are not in the overlap, just in the outside circle here, or the B circle. So like 0, 2, and 4 would be the rest of the elements in B, but not in the overlap. So again, the overlap is used to show the intersection of the sets. The whole set, everything in the two circles would represent the union. So you notice A union B would be all numbers inside both circles, right? Would be all numbers inside both circles. So this is a way we could actually write the intersection and union as a way to visualize it. And we use overlap. Venn diagrams use overlap to show that intersection, and they use circles to just include the numbers in the sets. So if we take this idea and we think about how are we going to compare two inequalities. So say we want to graph the solution to the compound inequality x less than or equal to 2 and x greater than -4. And with an inequality, we note like x less than or equal to -2, or excuse me, yeah, s less than or equal to 2 is an infinite set of numbers. So is x greater than -4. This is also an infinite set of numbers. So what that means is that we really can't list. So therefore we can't list the numbers. And then look at the list of numbers and tell which ones are common or which ones are the same. So then a way around this then is to compare the graphs. So we use the idea of like a Venn diagram and visualize the sets instead. So here's what we do. If we want to graph the solution to the compound inequality, and we want to actually compare these two sets of infinite numbers, then what we do is we compare their graphs, which is a visualization of the solutions, right, of the numbers. And these graphs are built on adjacent number lines. These number lines are basically lined up. So here's what I'll do. I'm going to graph x less than or equal to 2 on this number line. So there's a closed circle at 2 because it's less than or equal to, and then it includes all the numbers to the left. So this would be representing x less than or equal to 2. And then x is greater than -4. I'm going to graph that on the next number line below. So x is greater than -4. We'd have an open circle at -4, and then everything to the right. All right, so we're going to line up number lines. These are called adjacent number lines. We want to compare adjacent number lines. And if we look at what we want to find, we actually want to find x less than or equal to 2 and x greater than -4. And that's going to be an intersection. This is an intersection of the sets. An intersection is an and. So we can look on here and kind of, like I say, like the Venn diagrams, we can sort of look at, well, the intersection represents the overlap of where these number lines are defined. So if you think about looking at these, at -4, our two number lines start overlapping each other. And at 2, they overlap until they get to 2. So here's where the overlap occurs. So it looks like everywhere between -4 and 2 is where the numbers overlap. That means they're going to have the same values. If you look at 2, since I'm including 2 for x less than or equal to 2, and then it goes over the line where x is greater than -4, that means 2 is part of this overlap. The overlap, the intersection, this set does include 2, but it does not include -4. So there would be an open circle there because it does not, the solutions do not overlap at -4. So the overlap is where, and again, I can only see this if I line up my sets. If I line them up adjacent to each other, I can see where these sets, where these number lines, right, overlap each other. So if we think of this answer, this then is the actual graph of the answer of x less than or equal to 2 and x greater than -4. All right, so this is actually the answer that we're looking for when it says graph. We could also write this answer using interval notation. And these overlaps are pretty typical. The interval notation, it starts at -4, but doesn't include it. So I use a parenthesis. And then the overlap, it stops at 2, so I use a bracket there. All right, so these answers are pretty typical of when we have an and, or we're looking for an intersection between sets. So the shorthand notation, we call it, is a way for us to represent this intersection, right? The answer to this intersection are all the numbers, if you think about it, it's all numbers between, the word between, -4 and 2, including 2. So we use this word between, and we want to use that word between. And if you look at the shorthand notation, is actually putting these inequalities together. -4 less than x less than or equal to 2. If you think about the word between, x in the note in this interval, or excuse me, this inequality notation, x is actually between, and if you look at, like I say, the notation, and we could read this notation, if you read from the middle, you have x less than or equal to 2, so that's this part. And then if you read from x and go to the left, we'd have x is greater than -4. And you see that we have the two inequalities, but it's nice and compact, and the x is actually in between -4 and 2. So this is a good way to use this shorthand notation, what it's called, to represent numbers that are between two numbers. All right.